Hi friends, today we are going to discuss multiplication of large integer, right? And for this we are going to use divide and conquer strategy. So as we have studied basic concepts of divide and conquer, right? So how to perform divide and conquer? By dividing the problem into the sub problems. So in large, when you are talking about large integer, then multiplications are quite difficult to do the multiplications and will take a lot of time to perform the task. So if you see that if normal number you are going to multiply, right, then what will happen? Time complexity will go in quadratic, right? Because one number you are going to multiply with other number, digit by digit you are going to multiply. Wherein divide and conquer, what it says that we can reduce the number of multiplications. We can reduce the number of multiplications, or it may be then we have to increase the number of additions or subtractions. But our tendency is to decrease the number of multiplications. So let us see that with an example how you are going to perform the task. Okay, multiplying two larger integer. To demonstrate basic idea of algorithm, let us start with a case 2-digit integer. Say we are having 23 and 14. So 23 and 14, when you are going to multiply, generally what will happen, just we'll do 23 and 14 multiplications. So what will happen, we are going to multiply these 3 and 4, right? Then we are going to do multiplication between 2 and 3, 2 and 4 and 1 and 3. So this is basic ideas of multiplications. Same thing, so we are going to place it over here. So how many multiplications we are going to perform? One between 3 and 4, second between 4 and 2, then third 3 and 1, and finally we are going to multiply 2 and 1. So unit place we are going to multiply, then cross, then next place, 10th place we are going to multiply. So in this particular case 2 digit, how many multiplication is there? 2 cross 2 is 4 multiplications. If it is n digit values, here is 2 digit. If it is n digit values, then we have to multiply how many number of times? N cross n is n squared number of time. 2 cross 2 is 2 square. N cross n is n square. So that many number of multiplications you are going to perform. How it is? This 23 can be written as tens place, like 3 into 10 power 0, 2 into 10 power 1, right? So 2 into 10, 20 plus 3 into 1, 23. Similarly, 14 can be written as a 1 into 10 power 1 and 4 into 10 power 0. So if we add 10 plus 4 is 14. Now, in regular multiplications, natural multiplications, without using divide and conquer, how are you going to perform? If you are going to multiply this, as I said you, these 2 and 1 we are going to multiply. So one by one mathematically we will see that unit place we are going to multiply. Unit place means what? 4 and 3 are going to multiply, right? 4 and 3. So this is the representation of 23. This is the representation of 14. Now you can see that 3 and 4. 3 and 4 you have multiplied it. And what is the place? This is 10 plus 1 place. This is 10 power 0 place. So 10 power 0. 10 power 0 is nothing but 1. So 4 into 3 were multiplied. Here later on 4 into 2 and 3 into 1. When you are going to multiply 4 into 2 and 3 into 1, what is the power term? 10 power 1 into 10 power 0 is remain 10 power 1. 3 into 1 into 10 power 0 into 10 power 1 is remain 10 power 1. So here we can see that 2 into 4 cross 3 into 1. And what is the power term? 10 to the power 1. 10 to the power 1. Tens place. And finally, here we have 2 into 1. So we are going to multiply 2 into 1 is 2. And what will be the power term? Power term will be multiplication of 10 power 1 into 10 power 1. So 10 square. If we do regular performance of multiplication, what will happen? 2 into 2 is nothing but 2 multiplied by 100. Right? Multiply by 100. Here 2 into 4 it is 8. Plus 3 into 1, 3 into 10 power 1 is 10. Plus 3 into 4 is 12. 10 power 0 is 1. We'll add these all. What is the values? This will give you 200 plus, from here we'll get 110 plus From here you will get 12. So we are going to get 322. 322. So if you do the simple regular multiplications as we are doing mathematically, what is that? 23, 14 if you will go and multiply, 4 3 ja 12 will do, 4 2 ja 8, we are going to multiply it and we are going to add the carry forward 9, 3 1 ja 3, 1 2 ja, you are going to multiply 1 and 2, so 2. If you see that, we are getting the same answer, 322, right? So this is the ideas behind that. How many multiplications you are going to perform? We are going to count how many number of multiplications you are going to perform. I just said you that 2 cross 2 4 multiplications. What are that? We are multiplying 2 into 1. You are going to multiply third multiplications, 4 multiplications, right? Now mathematically what we are having the solutions for this is to reduce the number of multiplications. How will we reduce the number of multiplication is, we have already multiplying this 10th place and unit place. Is it possible to use this 10th place and unit place in order to find these multiplications values? If yes, then we will replace these 2 multiplications with 1 multiplications, right? And hence at the place of 4 multiplications, we are going to use 3 multiplications. Let us see that. This was our problem is 2 into 4, 3 into 1, middle part, 2 into 4, 3 into 1. Focus on this part. So 2 multiplication is there. Is it possible to use the previous concepts and reduce the number of multiplications? Let us see that. 2 into 1, we are already doing it. 3 into 4, we are already doing it. These 2 multiplications we are going to reduce with 1 multiplications. So how it is? We are going to add these values 2 plus 3, 2 plus 3. Second values you are having 1 plus 4. We have added, multiply it. After multiplications, you subtract these values or known multiplications. Why? Because this is the values of a plus b, right? And or you can say that a1 plus a2, b1 plus b2, right? So multiplication of these values, how it will give? It will give you 2 into 1, right? Plus, let us see that 2 into 4, right? Plus 3 into 1 plus 3 into 4. Out of this, you are going to subtract 2 into 1 minus 3 into 4. So we are having some common terms. Cancel. 2 into 1 cancel. So what you are getting? 2 into 4. Yes, and 3 into 1. We are getting the same multiplication. At the place of these 2 multiplications, how many multiplications you have used here? Only 1. These 2 are known to us. These 2 are known to us. So at the place of 2, we reduce by 1. So if we perform the task by using divide and conquer strategies, we are going to reduce the number of multiplications and hence will reduce the time complexity. So in regular multiplications, we are having time complexity of n square. So if you are able to reduce the time complexity by n square lesser, maybe it will be between n to the power 1 to n square, then we can say that yes, divide and conquer strategy of large integer multiplications has lesser time complexity. So let us see that. How to generalize this? So as we have seen that in previous case, A was 23, right? And B was 14. So what is the value of B0? 4, B1 1, A0 3, A1 2, right? 23 and 14. So now we are having C values. C values are going to multiply A and B. It means what? We are going to find 23 multiplied by 14. And what you are going to write it? We are writing here C2 10 square plus C1 10 to the power 1 or C0. So here we have our 3 values C2, C1, C0. If we see our previous complexity, solutions here, 10 square we are having, 10 to the power 1 we are having, 10 to the power 0 we are having. So this is C0, C1, C2. right? Now how are you going to represent this? At the place of C naught, as I said you that we are going to multiply A naught, B naught. We will write these in our regular values and try to do the multiplication. A naught and B naught will multiply. So here A naught and B naught is C naught, right? It will come here. Similarly, later on A1 B1 naught will apply, A naught B1 will apply. So for these we have replaced by the known factor by using one multiplication. At the place of this two multiplications, we are going to use one. What is that? A1 plus A naught plus B1 plus B naught minus C2 is known to us, C naught is known to us. Just now we have done it and we got the same answer, 2 into 4 and 3 into 1. Okay, so now these three terms you are going to use in order to decrease the complexity, right? So let us see that whether we are going to get the same answers or not. So what is that? C2 is A1 B1. A1 B1 is nothing but we are talking about 2 into 1. 2 into 1. Right? Similarly, C naught is A naught B naught. A naught B naught is 3 into 4. And A1 plus A naught is nothing but 2 plus 3 is 5. B1 plus B naught is 1 plus 4 is 5. Right? Minus C2. C2 is nothing but 2. C naught is 12. 2 plus C naught is 12. Right? So total value is 25 minus 12 plus 2, 14 is nothing but 11. Now you applied it over here. What is the C2 values? 2. 2 into 100. 10 square is 100. C1. What is C1 values? 11. 11 into 10 to the power 1 is 10 plus C0. What is the C0 values? 3 into 12. So 3 into 4 is 12. So if we add this, we are going to get 322. It means by using the divide and conquer strategy, we are able to reduce the number of multiplications. Now, this is our duty is to generalize this in general form. So let us see that how you are going to generalize it. It was 2-digit values. 2-digit values. We can see that we are getting first term along with C2 we are getting 10 to the power 2. Right? 10 to the power 2. Next term 2 divided by 2 is 1. Right? So basically at the place of this you are going to say that if number of digits are n, then first values you are going to multiply by 10 to the power n. Second values will have some constant values, multiply by 10 to the power n divided by 2. Right? So 2 divided by 2 is 1. Right? So it will go and decrease by n by 2 factors. N by 2. Next will be n by 4 kind of things. Because it is divide and conquer, we are dividing the power terms by 2 to 2. Let us see that. How you are going to discuss in general form, right? How you are going to perform large integer multiplication by using the divide and conquer strategy. So A, we are writing A1 A naught, right? And A1 A naught can be written mathematically as a A1 10 to power n by 2 plus A naught. B1 B naught, similar way. Now you will be wondering that how you are going to write this 10 to power n minus 2. How many number of digits we have? 2. So A1 is nothing but A1 into 10 to the power 2 divided by 2 because number of digit is 2 plus A naught. So what is that values? A1 into 2 divided by 2 is 10 to the power 1, 10 plus A naught. A is going to be A1 A naught. Same values you will be getting it. What is the value? 10 to the power n by 2. Probably you understood this. Similarly, we can do for B, B1 into 10 to the power n by 2 plus B naught. Now, by knowing this multiplicative factor C, C2, C1, C naught, Let us see that C is equal to A into B. What we are writing here? First term, A1 10 to power n by 2 A0. First A representations. Similarly, this is for B representations. We are going to multiply these two. Right? So, how are we going to multiply? A1, B1 will come together and 10 to the power. What I said you that if it is 2-digit integer, so power values are 2. Right? So, here since it is n-digit integer, so power values are 10 to the power n. Similarly, cross multiplications. A1 B0 plus A0 B1. Right? What is the power terms here? Into 10 to power n by 2. Just half. 10 power n, here 10 power n by 2. Plus A0 B0. A0 B0. Similarly, we can simplify by using C2 10 power n, C1 10 power n by 2 and C0. Rather using this, we are going to use these C values C2, C1 and C0. For this C1, I said you that formula, we are going to apply by adding the unit place values, by applying the tens place values, multiply it and subtract these known values C0 and C2. So there is no difference in values. We have to understand this part. How many multiplication is needed? 3 multiplications. Right? So 1 less. Similarly, we have to discuss, right, how it is beneficial. Large integer multiplications is beneficial, right, by using divide and conquer strategy. So T of n, time complexity, right, how many multiplications you are going to use? 3Tn by 2. Means you are going to perform the task T of n by 2 is problem size after division, and this 3 is type of multiplications. So if you see in previous iterations 1, 4, you will do like this divide and conquer strategy. So if we are going to apply 2 by 2 is decreased by 1, 1, 1, 1 by 1. The order is decreased by half. So problem size is decreased by half, T of n by 2. And how many multiplications are being used? Not 4. At the place of 4, you are going to use 3. So we have 3Tn by 2. Now, question is, if number of element is more than 1, we can divide it. We can divide and perform the task. But if number of element is 1, are we in the position of dividing this integer into 2 parts? No. If you are not able to divide the problem into the sub problems, we are not able to use the divide and conquer strategy, then here time complexity, if number of element is 1, just we are writing here 1. Right? Because you are not going to divide the problem into the sub problems, just we are going to do 1 multiplications. For that only we are writing 1. Just to multiply and write the answer. Okay. So by using backward substitution rule, as we have discussed earlier, this is 3Tn by 2. Problem size is decreased by 2. Next iterations, what will happen, friend? 3. This T of n by 2 becomes general term T of n. So you can write it 3T n by 2 by 2. Right? So this can be simplified 3 square T of n by 2 square. Right? Similarly, in third case, 3 to the power q T of n divided by 2 power 3. Now, when to stop this journey? When to stop this? When to stop? When value of n becomes 1. When will be 1? If n and 2 to the power, that values will be 1. So we are going to consider, we are going to assume here, assume n is equal to 2 to the power I. So after I iteration, what will happen? After 3 iteration is like this. After I iteration, 3 to the power I T of n divided by 2 to the power I. Now what I said you here? We are assume this n is equal to 2 power I. So n divided by 2 power I becomes 1. So we are going to write 3 power I T of 1. Right? If that is the case, what will happen? T of 1 is 1. So 3 to the power I into 1 is nothing but 3 to the power I. Now we have assumed n is equal to 2 power I. So can we simplify it? Yes. take log both sides. Take log both sides, right, on base 2. What will happen then? Log n base 2 is equal to I. Since I was not given in the problem, we have to replace this I. So if you are going to replace this I, how are you going to write? 3 to the power log n base 2. Right? Now, by using property of algorithm says that yes, we can have, if question is like this, a power log n base b can be written as a n to the power log a base b. So we can change, we can swap this. Again, I will repeat, a to the power log n base b can be written as n to the power log a. N and a will get swapped. So by using this property, we can write it over here is n to the power log 3 base 2. Log 3 base 2. And if you are going to write this log 3 base 2, it is n to the power log 3 base 2 is going to be n to the power 1.585. Just I said you that in the regular multiplications, we have time complexity of n square. If number of digits are n and you are going to multiply n digits, time complexity will be n square. That many number of multiplications you are going to use. Here in this, by using divide and conquer strategy, we are able to reduce the number of multiplications. Hence, time complexity is n to the power 1.585. So, it means this n to the power 1.585 is lesser than, this value is what? Lesser than, this value is lesser than regular time complexity is n square. It is less than 1.582 is less than 2. Hence, this is more effective, more efficient compared to regular or general integer multiplications. So, summary, as you have discussed large integer multiplications, regular method used to take more amount of time to perform the task because of more number of multiplications. While by using divide and conquer strategies, we are able to reduce the number of multiplications by increasing the number of additions or subtractions. Right? Hence, we can say that divide and conquer strategy is better to perform or to reduce the complexity of large integer multiplications. Thank you.